In this problem, we once again are looking at a bar with 4 external loads applied to it. And instead of looking at the force in the middle as we did in the last problem, we're looking at the force between C and D, so a little bit to the right of the middle. Once again, external equilibrium has already been applied to this problem, and we have the opportunity to look at calculating out what FCD is between C and D. Now, there are two approaches that we might take to this problem. The first approach would be to keep the left side of the problem and cover up or make a slice between C and D and remove this point D. So when we do that, what we see is a situation where there are 3 external loads and an internal load FCD. Now this internal load we're going to define as coming off of the open face in the positive x direction. We typically define the open face with a normal vector coming out of it for its coordinate system as being positive. We can then go ahead and apply equilibrium to this system. And we see that FA is in the minus x direction, and the rest of the forces follow as we see here. We solve for FCD algebraically, and we plug in the numbers that we've been given to find out that FCD is minus 262 newtons. Now, another approach would be to cover up the left side of this problem that we see here and look at the effect of this external load FD. So what we have is that FD is acting on the right side. This is the slice. Now we've defined a positive x direction to be coming out of this slice. So when we do the equilibrium, FCD, we could say is positive. Doesn't matter too much in this case, but again, we want to follow conventions to be able to communicate with others clearly and to also not confuse ourselves, quite frankly. And we have FCD minus FD is equal to 0, which means that FCD is equal to FD. Now, how do we get FD? Well, we can go back and say, look, we have already used external equilibrium, and we can solve for FD accordingly. So FD is going to be equal to FA minus FB minus FC, like we see here. And FCD is equal to FD as we solve using the method of slices. And look, FA minus FB minus FC is exactly the same as what we had here, right? Or we could just plug in the numbers, and we see that we are going to have the same result, where FCD is minus 262 newtons. Note that FCD, this force in between C and D, is negative. Okay, so what does that mean if we were to ask ourselves, is this region in compression or tension? Well, our definition of tension is that if it's coming out of the face, and it's positive, it will be in tension. If it's coming out of the face and it's negative, it will be in compression. So because FCD is less than 0, we know that this region CD, is in compression. Okay, and once again, we'll go ahead and solve the numerics using Colab. Again, I think it's just a nice idea to get somewhat familiar with Python through practice. So we come over to our Google Drive, we create a new Colab file. We are going to repetitively, you don't have to create a new script every time. You can go ahead and use the same one over and over again and just have a bunch of different cells for a whole problem assignment. It doesn't matter too much, and a lot of these variables and parameters are even the same, so it would just be changing the numbers in our problem. So FA in our case is 28. FB B in our case was 27 maybe? Or minus, or it's 177. Great. Okay, 177. And FC, you can see that my memory is not the bestest. It's 113. Okay, and we will do FCD is equal to FA minus FB minus FC. And we'll say that the units are going to be in newtons. We print our answer. And I think actually we'll give it a space. And oh, what happened? I made a mistake. Oh, FCD is not defined. Well, yeah, that's truth. Okay, so minus negative 200 or minus 262 newtons. Thank you.